It is a fact that the Magnavox Company was incorporated in the state of Arizona August 2, 1917. However, the beginnings of the Magnavox story occurred around 1911 with the quest by two men, Edward Pridham and Peter Jensen, for the perfection of a supersensitive type of telephone receiver for long-distance lines and for radio reception. This information has been collected by me over the past 40 years from various sources. Unfortunately, I do not know the present whereabouts of many of the photographs you will see here. The name Magnavox and incorporation under that name does not come about until 1917. The backstory begins circa 1909 when wireless equipment invented by Valdemar Poulsen of Denmark is chosen to establish a west coast of USA communications network in competition to land telegraph and telephone. Peter Jensen had been an apprentice to Valdemar Poulsen since 1902. Carl Albertus had achieved a rank of master mechanic in the trades in Denmark, and Douglas Parham, a native Californian, was working as an installation engineer. The Poulsen system of generating continuous wave, CW, radio frequency radiation using an arc converter, sometimes described as a super-audible singing arc, was used to transmit Morse code via intermittent CW, or more practically a form of frequency shift keying. But they could also achieve audio modulation of the RF by inserting high current rated carbon resistance microphones into the antenna circuit of the transmitter. The hope was that radio telephony could be developed to compete with the already established long-distance wireline telephones of the Bell systems. Note the high current carbon microphone for audio modulation of the CW arc converter. Two men, Peter Jensen and Edwin Pridham, were brought together in 1910 by their employment in the newly formed Poulsen Wireless Telephone and Telegraph Company. A few months later, the company was reorganized as the Federal Telephone and Telegraph Company. Albertus, Jensen, and Pridham were to set up stations in San Francisco, Stockton, Sacramento, and Los Angeles. The hope was that radio telephony could be developed to compete with the already established long-distance wireline telephones of the Bell system. Wireless telegraphy could succeed over even greater distances, and there were experiments to prove the possibility of transmitting high-speed code from punched paper tape readers. Finances for this venture ran out, and Albertus, the master mechanic, Jensen, and Pridham completed the installation of two stations with no pay. But demonstrations impressed a new group of investors, including Richard O'Connor, to inject new money, and salaries were resumed, but they were obliged to take half their back pay in company stock. While these stations were successfully installed and working, voice communications with Los Angeles was unreadable at certain times of the day. The signals were just too weak. Again, note the high current carbon microphone for voice modulation, but certainly not used for the full power operation. A group of San Francisco investors, headed by Richard O'Connor, held a large block of the company's stock, but could not gain control of the organization. They thought they should pursue other opportunities in the wireless field by trying to buy the remaining worldwide licenses for the Poulsen system. They persuaded Jensen and Pridham to resign their positions and accompany an investor named Coburn to travel to Denmark to negotiate with Poulsen. A shocking revelation on arrival. A British syndicate had just secured options on all remaining licenses. they found themselves dead in the water, so to speak. They were so impressed by how well the Poulsen arc system could be audio modulated at low power. They wondered if they could develop worthwhile improvements. While on the continent, they went to Berlin to meet with Dr. Emil Huth, but he could not offer any good alternatives to Poulsen's system. But while there, they were able to purchase 2 high-current carbon microphones they judged of superior design. They traveled on to Paris to interview Baron von Leppel, who had a quenched spark gap system coming close to CW operation, but they judged it quite inferior to the Poulsen methods. They returned to London to rejoin investor Coburn, who had never made it to the meeting with Poulsen. Turns out he had been on a drunken binge the whole time. Nothing left but for the trio to return home to face the music. The failure of this trip was a blow to the young men, but they were still able to maintain the confidence of O'Connor and his group of investors in the future of radio communications. By February 1911, with the financial backing of Mr. O'Connor, the 2 men were set up in a new venture called the Commercial Wireless and Development Company, in a leased house and outbuilding in Napa, California, about 40 miles northeast of San Francisco. Peter Jensen and Edwin Pridham are joined by Peter's good friend and associate, Carl Albertus, and Hugh Sim, a journeyman mechanic. Pridham and Jensen decide to investigate making a more sensitive earphone for wireless. They also recognize that the telephone companies had the same difficulty in extending their long-distance service in such a large nation as the USA. That, they thought, would actually likely be their primary potential market. Some of you might recall that in 1910-1911, there was yet to be any disclosure of a practical way to amplify feeble long-distance radio signals captured by any receiver antenna system. These were the days of spark, arc, and high-frequency alternator transmitters. The radio receiver could only do a poor or good job of delivering that captured energy to an earphone, and the earphone could only do a more or less efficient job of converting that electrical energy into sound waves. It is only apparently by serendipity that the remarkable threshold sensitivity of the human ear made spark-era communications at significant distances work at all, with our ability to sense audio vibrations measured at about 1/1000th of a standard atmospheric pressure. They went straight to work on developing a more sensitive telephone receiver. They don't realize it yet, but they had acquired insights that will put them on the way to developing a successful public address system. They had considerable experience in using high-current rated carbon microphones to modulate arc transmitters. They were aware of 1909 experiments in high-speed radio telegraphy to use an Einthoven string galvanometer consisting of a single gold or silver-plated quartz fiber suspended at right angles to a very strong magnetic field. A slit of light could be focused on the fiber and thus be modulated by the deflecting fiber. The light was focused on a moving strip of photographic film. On development of the film, the 300 to 600 word per minute machine-driven Morse code could be read. Very sensitive, but they were seeking real-time audio reproduction. Just as a footnote, you might like to ask, where did this so-called string galvanometer idea come from? The answer lies in the first successful experimental apparatus to detect and record on photographic film the electrical activity of the heart, circa 1902. The first electrocardiograph vacuum tube amplifiers for EKG service were not employed until about 1927. They had experience with high-flux electromagnets used to control the Poulsen arc converter, and lastly, they had experience in transformer design that will eventually carry over into the audio domain for matching telephone circuits to low-impedance loads, as are characteristic of moving coil dynamic reproducers. Building on the Einthoven theme, they reasoned that they might simply suspend a single taut wire carrying feeble audio current in a strong, constant electromagnetic field. Then link the wire with something as simple as a short matchstick glued to the center of the wire and to the center of a light diaphragm centered over an ear cup. A day of work to set up an experiment was richly rewarded with much better than hoped-for results, and within a few months they had developed a very sensitive unit making use of the moving coil principle. Believing this to be a unique application of the principle, they filed for a method patent. After a long delay, they were devastated to find their claims rejected, with citations referencing the work of Siemens and Lodge before 1900. No practical use had been made of those patents because their described construction made them inefficient in converting feeble currents to useful volume. But their receiver had the potential to be a highly effective unit for long-distance telephone circuits in the age before vacuum tube amplifiers. They labored for about 2 years to build a robust unit that they were very confident would be of great value to the American Telephone and Telegraph Company. Samples were sent to Western Electric for evaluation. They had little to say about the performance, but were critical of the excessive weight of their instrument, weighing in at some 30 pounds. In the next 2 years, they labored at weight reduction and successfully developed a matching transformer to couple ordinary telephone line impedances to the low impedance of the moving coil circuit, therefore significantly increasing overall efficiency. By November 1914, they were ready to demonstrate their telephone at the Independent Telephone Convention in Minneapolis. Interest was considerable, but no stock was sold. But now they were convinced that they were ready to submit their improved telephone to AT&T again. They gave demonstrations to their chief engineer, and he requested time for additional testing. During their visit to New York for the demo, they met with Dr. Lee DeForest and learned that he was in discussions with AT&T for rights to the 3-element vacuum tube. After several weeks waiting, they received a statement from AT&T, quote, "We regret, not interested. You may obtain the instrument submitted for test by applying at the shipping department," unquote. Jensen and Pridham return home and soon visit the Panama Pacific International Exposition being held in San Francisco. They are in for another shock. AT&T demonstrated long-distance telephone communication using vacuum tube amplifiers for the first time. Poof! It appeared that there was simply no longer a substantial market for relatively high-cost, high-sensitivity telephone receivers. After 4 years of work, the efforts had only yielded something like a $30,000 loss to investors. As a side note, you get extra points if you recognize the portrait of David Hughes, who widely gets credit for invention of the carbon microphone in the late 1870s. They still hoped that the independent telephone companies would have some need for their receiver, since AT&T was not about to license the vacuum tube amplifier circuitry to their long-distance competitors. Around May of 1915, a blacksmith and baseball fan visited the lab in Napa for a demonstration of their telephone. He mentioned that he had difficulty in hearing the announcements shouted out through a megaphone at the baseball park, and wouldn't it be nice if their earphone could service multiple earpieces or maybe even megaphones around the park. An Edison cylinder phonograph with large signet horn was in the lab, and in an idle moment, one of the men decided to hold the rubber tube from the earphone to the horn throat while an associate named McCarty was speaking on a phone line from San Francisco. They were absolutely astounded by the volume. It was such a revelation to the little band of inventors that they saw fit to have a celebratory photograph taken that afternoon. They probably did not know that there were already in manufacture intercom and even very modest public address systems using telephone-type carbon microphones and magneto-attractive diaphragm telephone earpieces fitted with small horns. These diaphragms only moved back and forth a few thousandths of an inch to generate sound pressure. The Magnavox moving coil reproducer could easily move 6 or more times as far with far less mechanical loading caused by the rigid peripheral clamping of the old planar diaphragm. They immediately understood that their moving coil reproducer could handle much more power when driven by a high current rated carbon microphone, such as was being used in the modulation of small arc transmitters with which they had considerable experience. It might prove interesting to note that these first loudspeakers use a different driver construction than their post-World War I loudspeakers familiar to many radio collectors. The rectangular moving coil bobbin of their telephone receiver, with relatively small diameter wire and more turns, was changed to a bobbin-free coil of heavier gauge wire and fewer turns, skewed and pressed flat to present a wedge of parallel wires within a broad gap between two series electromagnets energized by 6 to 12 volts DC. This method worked, and it was loud, but it was difficult to fabricate. It needed improvements that would be delayed, as I will soon explain. Here you get to see the wedge-shaped profile of the coil, where it is evident that much of the mass of the coil is outside the magnetic gap. This mass definitely limited the high-frequency response of the loudspeaker. Note that this patent disclosure drawing shows the use of a transformer to match the microphone circuit energized by 6 to 12 volts to the low impedance of the voice coil. The horns of previous products could only handle a fraction of a watt of power, while their first product, manufactured under the MAGNAVOX name in late 1915, was later rated at 10 watts, and by 1919, 25 watts, all without vacuum tube amplifiers. It was said that 2 of them, set up in a plaza or stadium, could allow a speaker to be heard by more than 50,000 people. Rumors were flying in Napa about loud voices and even music being heard in the area. The Mare Island Naval Station was only about 15 miles away and had been operating various wireless stations there since 1902. In 1915, Lieutenant Commander George C. Sweet was transferred there with primary responsibilities to oversee ongoing operations to upgrade all manner of communication systems. Sweet was driving through Napa one day and heard these amplified sounds and soon found the origination. The inventors gave him a demonstration on the spot, and soon Sweet arranged for them to do a demonstration at the naval base. As a result, Sweet arranged for the acquisition of the first complete PA system sold by the little company. An invitation was received to exhibit at the Panama Pacific International Exposition, but they had not yet completed their patent filings. They did, however, operate their equipment under secrecy halfway up in the towers of the Tower of Jewels at the exposition. There was still much to be done to understand how best to apply the equipment in outdoor locations and make the drivers rugged enough, so it was late 1915 before they thought they could officially disclose the invention to the public. That official debut took place December 24, 1915, from the balcony over the entrance of the new San Francisco City Hall in the Civic Center. From the first demonstrations, a phonograph provided music and singing in addition to the orators. They had designed a special tone arm assembly for an acoustic phonograph with an integrated high-power carbon microphone that could regulate power to the loudspeaker in the same way as the usual high-current microphone. Such demonstrations brought great publicity, but they were not likely going to service a market needing large quantities of public address systems anytime soon. They needed to develop other products, and their little shop could do no production work. A move was made in mid-1916 to 156 2nd Street in San Francisco. Later in the year, after securing an order for 100 compact dry cell powered PA units, they leased larger facilities at 256 Mission Street. They designed the first phonograph to use electrical amplification in early 1916, but could find little interest from Victor or Columbia. Columbia was said to be somewhat distracted by their involvement in making wartime materiels. They turned their efforts to developing a smaller system that could be adapted to an existing phonograph and serve a small ballroom or clubroom, the unit being powered by 12 number 6 dry cells connected in series parallel to yield 6 volts. (1917). Their continued development work kept them in need of new phonograph records that they purchased at the Sonora Phonograph Shop in San Francisco. They were buying multiple copies of the same records, and the owner of the Sonora Phonograph Distributorship Company, Frank Steers, was curious as to why. He received a demonstration of their experimental work and was impressed by the potential of their project. Steers possessed the retail marketing and administration capabilities that Commercial Wireless and Development Company were completely lacking. O'Connor, Jensen, and Pridham agreed to Steers' proposal to merge the two into a corporation to be known as the Magnavox Company, and Sonora phonographs would be included in their PA systems. The Great War, World War I, changed the company focus radically. While the merger was in process, Pridham and Jensen were called on by Commander Sweet of the U.S. Navy to develop an anti-noise microphone urgently required for aircraft radio telephony and cockpit intercom between pilot, spotter, bombardier, or gunner. Many hours were spent next to the deafening roar of Liberty airplane engines mounted on test stands at the Hall Scott Liberty Engine Works in Berkeley, California. All attempts to isolate the noise from the microphone element failed. In desperation one day, one of them made a comment that keeping the noise out was impossible. We may as well just let all the noise in. That proved to be the eureka moment to solving the problem. Just let the noise impact both sides of the microphone element with equal force, while permitting the speaker's voice to act only on one side of the element. They devised an elegant yet simple device to perform the function. This new anti-noise microphone, when coupled to their high-volume output moving coil telephone receiver, resulted in an ideal intercom combination, not only for aircraft, but for marine telephone systems, so that by the end of World War I, some 270 Navy and over 1,000 merchant marine vessels had their intercom systems installed. This highly profitable marine telephone system usually employed up to 5 stations, with each having a separate bell ringer. Immediately after the war, they were marketing the system for commercial applications. It is not known if this product application produced much additional business. A short Google search shows almost no references to it past 1919. An interesting side note is that in 1919, they received a contract from the government to design and build the intercom systems for the yet-to-be-built ships, the Saratoga and Lexington. Each system had 3 interlocking master control cabinets with 350 loudspeakers on 7 different circuits. Any one or all 350 speakers could be operated at once. The hardware was tested and accepted by the Navy in 1920. It was not until 1927 that the system was installed, and when it was tested, only a few speakers could operate at all. When the system was designed in 1919, there were no vacuum tube amplifiers being used in their system. Their low-impedance horns were being driven directly by high-current microphones. But the contractors wiring the ships sometime around 1925 presumed that the speakers used high-impedance drivers, as were common on broadcast radios. There was far too much resistance in the distribution wiring to service these low-impedance loads. The Navy decided that the wiring mistake was too costly to correct, so the 1919 equipment was removed and most parceled out to smaller ship applications. Magnavox was not held liable for this contractor's snafu. A 1918 view of the Mission Street factory, captioned as Assembly of Anti-Noise Telephones. The caption reads, Airplane Transmitting Systems for Government, 1918, San Francisco. There appear to be well over 100 people packed into this work area. Note all the overhead machine belt drives. It appears that there are multiple electric motors mounted up in the rafters. The caption reads, Airplane Communication System Factory, 526 Mission Street, San Francisco. There was a stated goal of making all parts in-house and to a very high standard. In this photo, you can see women operating machinery. This was a new reality for American industry, precipitated by all the men going off to war. In 1919, the company is free to begin to ramp up the setup of large public address systems outside of San Francisco. First, at a bond rally in Washington, D.C., in April, where the Magnavox anti-noise microphone drove a radio transmitter in an airplane flying at 3,000 feet to address a crowd of 10,000 gathered below. In Chicago, President Taft speaks on behalf of a Liberty Bond Drive rally. In New York, famous operatic and popular stage singer Fritzie Scheff does her part at another bond rally. With the exception of the Washington event, PA outfits are still using high current carbon microphones to drive the loudspeakers directly, but purpose-built vacuum tube amplifiers would be available for some applications before the end of the year. More publicity pictures. William DeMille on set of What Every Woman Knows, 1920, using Magnavox Type V2 telemegaphone. A frail President Woodrow Wilson speaking at Chicago. Suspended horns are microphones. The glass enclosed shelter for podium resulted in poor audio. 1919-1920 show the first Magnavox vacuum tube amplifiers using Moorhead Type C tubes, powering Type LS2 drivers, fitted with 24-inch quarter-sawn oak bells. The tubes were operated with plate voltages up to 500 volts, requiring custom-designed inner-stage transformers using interleave pancake bobbin construction on an open core, unlike the closed-core audio transformer designs used on most radios of the 1920s. This outfit was first demonstrated under the auspices of the Navy in Washington, D.C. At a church, horn microphones were used to pick up the voice of the minister, choir, organ, and surprisingly to me, miniature microphones were attached to a trumpet and violin for solo performances. The loudspeakers were placed on church towers, and it was said that the sermon could be clearly heard a half-mile away. Persons much farther away took note of the music. Ministers and evangelists of all kinds were quick to adopt public address systems and radio broadcasting to spread their word. This image is from a page of a scrapbook containing hundreds of topics and advertisements from 1919 until about 1926, maintained by an advertising clipping service for the Magnavox Company. I have no knowledge if this scrapbook still survives. (1919) The wartime manufacturing operations on Mission Street had far outstripped their requirements for efficient operation. An 8-acre estate property at 2725 East 14th Street, Oakland, was purchased to be the site of a new 2-story factory with basement. The estate mansion was retained as offices, and here we see some of the principal executives and engineers. The new factory building was hailed as an example of the best in factory architecture. 2 additions in 1921 and 1922 would triple the building size. This photograph probably dates from early 1920, captioned as a special power amplifier, 3-stage. First and second stages using Type VT2 tubes. The third stage using 4 Type VT2 tubes in parallel. From early 1922, these appear to be the first product data sheets published for high-power vacuum tube amplifiers. It is claimed that the amplifier will operate a total of 25 telemegaphone loudspeakers at maximum volume. It mentions use of Moorhead Type C tubes, but pictures clearly show Western Electric Type VT2 tubes installed. In 1919, the wedge voice coil, whose excessive mass limited high-frequency response, was replaced by a cylindrical coil over a coaxial field coil pole. Rice and Kellogg would begin experiments to match this field coil and voice coil arrangement to a cone speaker in 1921. Their goal was to match a cone-type loudspeaker to a vacuum tube-powered amplifier operated off of AC mains, but such a product was not going to be a commercial reality until 1925. Inside the Wellman Estate Mansion offices of Magnavox. Caption reads, Standard Music and Speech Storage Battery Operated Amplifier, 1921-1922, i.e. no vacuum tube amplification. Note the art glass window above. Numerous examples were a hallmark of this mansion. From a circa late 1923 sales brochure showing the components used in their highly successful R2 and R3 horn drivers. There was indeed a high standard of workmanship in their products. A view inside the new 14th Street Oakland factory floor, now with room for better workflow and better lighting. The R1 Telemegaphone appears to be the first product circa 1920 to be directed at use for radio communications, with a small horn that would efficiently reproduce tone-modulated CW. Note that there was an option to connect the driver to ear pads by way of a flexible tube to a headset for copying weak signals. I have personally never seen one of these headsets in modern collections. Note that the impedance matching transformer on the unit shown at right makes use of the layered pancake bobbin windings rated for up to 500 volts. (1921-22) Everyone in the industry is beginning to realize that broadcasting, in whatever form it turns out to be, will be big, really big. Note this very elaborate ham radio outfit owned by the Robinson brothers, licensed as 2QR in Keyport, New Jersey. They have a big Magnavox R2 loudspeaker, a carbon microphone fitted to a phonograph horn suspended from the ceiling, and in the lower right corner of the picture is a phonograph fitted with a Magnavox Telephonograph microphone pickup. In the right-hand picture, combination radios and toilet sets? Commercial illustrator Howard Brown produced a series of humorous renderings for Radio News speculating on how the industry just might play out for the consumer sometime soon. March 1922. An early example of marketing products to the radio broadcast listener. Send for details and receive the name of a distributor or dealer in your area. At right, a first example of folded leaflets available at shops and radio shows. The Magnavox products were expensive items, and advertising cuts associate their products with upscale scenes. Note the formal wear and the maid and butler listening from a doorway. Another folded leaflet. Magnavox products can bring the world of entertainment even to your holiday retreat. Alan Douglas reports that speaker production was 20 per day, with 50 employees at the beginning of 1922. But by June of the year, production had risen to 750 speakers per day, with 700 employees. But that did not last. By the end of the year, production was 100 per day, with 120 employees. When you come across a great publicity photo like this, there is no way that you can pass up the opportunity to show it. The balloon comment is my own. The picture most certainly dates from 1922. The brand of automobile is unknown, but is definitely a luxury model of the day. The receiver is a Kennedy Model 110, one-tube receiver driving a Magnavox AC2 two-stage amplifier connected to a Model R3B loudspeaker. Magnavox maintained a warehouse distribution facility in New York, but there was no doubt that they were at a price point disadvantage by having their manufacturing in Oakland. As the business became more cutthroat after the industry overproduction of 1925, this placed their basic profitability in great jeopardy. Magnavox gave up its New York office and warehouse in June of 1925. Their original consumer-grade amplifiers were upgraded in late 1923, but probably did not have a well-defined purpose, since it was rapidly becoming the norm to build receivers complete with two-stage audio amplifiers. These are quite rare in collections today. The print advertising budget for Magnavox kicked into high gear by 1923, having spent over $400,000 on their campaigns in that year alone. Publicity stunts involving Magnavox products were common. Here, circa 1923, is the world's largest loudspeaker, constructed for use at an amusement park. 1,000 board feet of select fir used in its construction, shown on the grounds of the new Magnavox factory building. Their horn speakers were a tremendous success, with estimates that over 400,000 of a record 19 models were manufactured in a 6-year period. Most of the horns were finished in a crystalline lacquer coating that required drying in a huge oven tunnel with trolley system, the whole affair being suspended from the factory ceiling. The oven was heated with rows of gas burners adjusted to produce high concentrations of carbon monoxide gas required for the lacquer to crystallize. Dangerous chemicals and a dangerous process that would be prohibited industry-wide in the late 1930s. Despite their roller coaster production schedules, the company was flush with profits from their loudspeaker business. They reasoned that they must expand to building radios, and why not build their own vacuum tubes? GE, Westinghouse, and DeForest were doing that, and more about that later. Their idea was to build what they would advertise as the first one-dial tuning, complete tuned RF radio receiver. Other makers would make that claim also, but this outfit does rank as one of the first and was beautifully crafted. Consistent with their California location with its Spanish design and arts and craft influences in vogue, the designers used open-grain oiled oak wood, almost unique for American radio cabinet design. The cabinet shown of the TRF-50 model contains a built-in horn speaker with a newly designed permanent magnet iron reed driver. The same chassis was available as a receiver only, with the recommended use of a Magnavox R3 horn or the newly introduced M4 reed driver horn. The chassis of these radios is radically different from any other American makers of the day. A person familiar with worldwide manufacturing practices would immediately think of German school of influence. Logical for Magnavox because of the very high standards adhered to by the Danish immigrant Jensen brothers and Carl Albertus, their master machinist. Die-stamped aluminum chassis and front panel, intricate die-stamped components of micarta and laminate phenolic board as basis for the D-type pancake variometers. Note the 3 white porcelain knobs in a row. Rack and pinion linkage to the single tuning knob. The assembled variometers are a thing of beauty, but must have required great skill and maybe too much time to assemble without damage. The bottom side reveals more intricately die-stamped parts. The white porcelain knobs shown 2 slides back actuate trimmer capacitors for each tune stage. Their adjustment was necessary for maximum signal and selectivity. Other makers claiming 1 dial, such as Thermiodyne, also had such trimmers on their front panels. Concurrent with the decision to make radios was their decision to manufacture what was conceived of as a non-infringing amplifier tube for their radios. This operation was under the direction of Herbert Metcalf. It would not turn out well. The first configuration claimed that the control element was not between the filament and the plate structure. There is no evidence that this tube ever made it into production. The first known production tube was named Type A. The filament and control elements are considerably different, with serrated offset teeth coming close to the filament. Not shown is a plate structure that surrounds these elements. This tube was described by Metcalf in the March 1925 issue of QST. The first production runs of the tube came in a cigar box wood, finger-jointed container. The tube base is brass with a black oxide treatment and die-stamped branding. Pins are staked into micarta buttons, crimped in place. Even the glass envelope is unique, being a straight tapered cylinder. These tubes with its wood box are apparently very rare these days. These tubes worked well in their first receivers. Shortly, the brass base was replaced by a beautiful Bakelite molding showing the Magnavox logo in all its glory. Adding to that the embossed paper, gold and green label on the glass gave the customer a feeling that he was buying the highest quality product. But he would soon be disappointed. These tubes exhibited a very high tendency to develop grid, or as they called it, control element, to filament shorts. As soon as the RCA patents on the 3-element vacuum tube ran out in early 1925, Magnavox was ready to go with a configuration that abandoned this element design. The new design for their tube is designated Universal Type 201A. It uses 2 oval spiral grid structures welded to vertical stud wires and connected in parallel. A single filament passes up through one spiral and down through the other. Such a structure is thought to have only been used in QRS branded tubes, but for unknown reasons, this complete redesign did not solve their general reliability problems. Magnavox had geared up for high-volume manufacture of these radios. This photo was used in their promotions to distributors. Why shouldn't they get in on such a big operation? Gimbel Brothers, New York City, 1925. Window display showing only Magnavox TRF-5 receivers and M1 horns. Heavy competition from industry overproduction has lowered the initial sales price of the TRF-5 from $125 down to $89.75. Gimbel Brothers operated radio station WGBS from 1924 to its sale in 1932. Of the estimated 65,000 radios made by Magnavox in the 1920s, only about 10,000 were thought to have been built using this chassis with ganged variable inductor tuning. Circa 1924 window or door decal for retail shops. The outfit on the right is a translucent screened glass panel in a wood frame mounted to a light box. Charming publicity booklets for the kiddies containing verses and pictures. The item at right is a stand-up counter card for shops. The clipping service scrapbook and foreign publications indicate export sales to at least Japan, China, Italy, and various places in South America. In 1924, Magnavox began making the M1 horn. The driver mechanism did not use an electromagnet or moving coil assembly, but used a moving iron vane armature operating in the field of a permanent U-shaped magnet. The diaphragm was connected to the armature by a steel pin. This horn, although not able to produce the exceptional high volume levels of the R-series horns, could be economically operated with radios not using large 6-volt lead-acid storage batteries. These horns could be integrated into public address systems for schools, hospitals, and factories at a lower price point. To try and minimize the heavy seasonal retail sales volume fluctuations for radios, there were some attempts to diversify circa 1924. This space heater product line continued into 1929 and was said to have been moderately successful. Other products were attempted, such as a laying cage for chickens, automatic egg cooker, and faucet-mounted on-demand water heater, and this Magnalux adjustable lamp. Only the lamp made it to volume production, with some tens of thousands being made up until 1929. In 1926, they acquired an aluminum foundry next to the 4-acre plot in Emeryville, California, where they built a new, smaller factory for loudspeaker production that was occupied in mid-1927. In 1925, there was some sort of struggle for control of the company. The primary investors through the business heydays of World War I and the first radio boom of 1922 lost control of the company. As a result, Peter Jensen resigned and went off to develop his own version of a moving coil cone-type loudspeaker. His departure included licenses to use his Magnavox patents. With the help of two wealthy brothers by the name of Oliver, Jensen was setting up a Jensen Radio Manufacturing Company factory just across the railroad tracks from the newly acquired Magnavox property in Emeryville, California. Within 2 years, the business was said to have captured 60% of the independent radio manufacturer speaker business and continued into the 1960s to be a leader in loudspeaker design. The Jensen Radio Manufacturing Company would move to Chicago by 1930. For the 1926 model year product line, the expensive-to-manufacture ganged variometer scheme of their Type TRF-5 and 50 receivers were going to need redesign, if for no other reason but to deal with their need to abandon their Type A vacuum tubes that had damaged their reputation with distributors. Gone were the arts and craft open-grained oak cabinets, with a turn towards the industry-wide preference for mahogany veneer cabinets finished in gloss lacquer. The variometer scheme was replaced with a straight-line 3-gang tuning capacitor designed and patented by Edwin Pridham. The chassis was now contained in a drawer, and the power connections were made via a multi-circuit plug. This works-in-a-drawer scheme would reappear decades later in their television sets. The caption reads, "Receiving Set Assembly Room. Section showing part devoted to toroidal coil. Used in Model 75, 1924." But actually the photograph must have been taken no earlier than mid-1925. I know that Magnavox had a lavish print advertising budget circa 1923-24, but here we see that they also ventured into sponsoring some musical features on the radio circa 1927. It appears that the first cone-type speakers for Magnavox were introduced in 1926, using an upgraded version of the driver mechanism developed for the M1 and M4 horn speakers, and these speakers were being offered to other radio manufacturers. These were good performing speakers of the day, but could not compete on price in the major markets east of the Rockies. In this 1926 product sheet, note that their vacuum tube is still being designated as the Type A and at a low price. Sometime in the year they would begin to sell their universal Type 201A as pictured a few slides back in this presentation. Alan Douglas reports that Magnavox produced only 60,000 radios in a 3.5-year period. They faced a hard reality. By mid-1925, the radio manufacturing market was saturated by extreme overproduction. Their new 5-tube 1925 model radios did not sell as well as expected in that environment, and distributors were left with large excess inventory. When it was time to introduce new 1926 models, the industry expectation was that the market would want 6-tube sets. They decided that if they did that, the old 5-tube sets would not sell at all. So the new models kept the 5-tube lineup. The market did not reward them. 5-tube sets were just not selling. While the recession of 1926-27 is considered relatively mild, it hit the radio business especially hard, with many closures and mergers, amplified by the necessity for surviving companies to come up with capital to invest in making good-performing AC-powered radios. Magnavox radio production and tube manufacture come to an abrupt end mid-1927. The company had produced about 200,000 vacuum tubes, but because they could not solve their dismal tube reliability of what looked to be a beautiful product, they had suffered a net loss of about $1 million on the tube venture. Their distributors lost faith in their ability to rectify the problems. The final straw was when the board ordered life testing of some 600 tubes, and it is reported that no tube lasted more than 5 hours. The board immediately ordered a shutdown of the tube and radio production. By 1925, their 14th Street Oakland location was becoming a retail area, and Montgomery Ward wanted to build a large retail store and a West Coast distribution warehouse that would extend onto the Magnavox property. They made a very attractive offer to Magnavox to purchase the property, and Magnavox would vacate within 3 years. In 1926, Magnavox acquired a 4-acre plot in Emeryville, California, believed to be at 4250 Horton Street. After the shutdown of radio and tube manufacture in mid-1927, Magnavox would limit itself to building a line of loudspeakers, mostly as an OEM supplier to the likes of Crosley, Zenith, Sears Roebuck, Colonial Radio, etc., with just a few minor exceptions to be mentioned shortly. After the departure of Peter Jensen in 1925, Magnavox continued to develop their own moving coil cone-type loudspeaker at a slow pace due to management problems. They were built as standalone units with field coil energized by copper oxide rectified direct current. Other versions of speakers contained their own integrated triode power amplifier and half-wave or full-wave tube rectifiers. Initially, these power amplifiers experienced early failure of their large-value paper dielectric capacitors and further damaged their reputation. However, the reliability was eventually solved by selection of another supplier, and the new version becomes the model R500. In early 1928, they were ready to introduce 7 new speakers. All in this series were designed to feature 2 interchangeable subassemblies, the cone head and the field coil assembly. The field coil winding, to suit a customer's particular requirements, could be dropped into the back assembly with little labor or special tooling. By 1929, there were 25 versions over their catalog of nominal 8, 10, and 12-inch cones. Magnavox sets up an assembly plant in Chicago with operation by the spring of 1929 to avoid the expense of having the field coil and transformer wire shipped cross-country twice. Magnavox even provided speaker parts to radio manufacturers that wanted to wind their own field coils and transformers. By 1928, the Emeryville factory was said to have been operating at a full capacity of 4,000 speakers per day, right up until the end of 1929. But confusion comes when I find this October 1928 issue of Radio Doings Weekly magazine reporting on the new assembly room just added to the Magnavox factory in Oakland. The breezy tone of this news copy has me wondering if the plant location is just misreported in a rewrite by a magazine reporter. They were selling direct to radio manufacturers, but they still attempted to sell standalone speakers at retail through distributors, some with integrated power amplifiers. But standalone speakers for the late 1920s AC-powered radios lasted scarcely more than 2 years, so sales volume appears to have been very low, despite an apparently generous initial advertising budget. They were gone in the advertising by early 1930. These speakers would turn out to be the last retail products sold until 1937. In 1928-1930, the company faced these realities: dwindling need for separate loudspeakers sold at retail by independent makers such as Magnavox. No other volume product lines identified to move into from their Bay Area locations. They still know how to make very good loudspeakers, but their raw material suppliers are in the Midwest. The majority of their independent radio manufacturing customers are also located in the Midwest. They opened an assembly operation in Chicago sometime in the spring of 1929. Negotiations are underway in 1929 to acquire the Mershon electrolytic capacitor division of the Amrad Corporation. After the crash, a radical reorganization of the company is undertaken. The Emeryville plant is closed early in 1930, marking the end of Magnavox manufacturing in California. All usable machinery and 45 staff moved to Chicago, but all but 2 would leave the company within the next few years. In 1930, Magnavox completes the acquisition of the Mershon line of electrolytic capacitor products. The Chicago plant is determined to be unsatisfactory, and they learn of the availability of a virtually new factory building owned by the Greater Fort Wayne, Indiana Development Company. This plant had just been vacated when the Steinite Corporation was forced into receivership. By 1931, they had acquired the facility located on Buter Road and would remain there and later at expanded facilities to support new consumer electronics products in Kentucky and Tennessee during the next 50 years. So there is still much more of the Magnavox story to be told, but not in this presentation. This lecture could not have been prepared without the assistance of the following collectors and amateur historians over the last 40 years, or without assistance of the Magnavox Consumer Electronics Company in Knoxville, Tennessee during the 1980s, permitting me to photograph original documents one afternoon. And finally, my thanks to Billy Malone, who wrote the early history of the Magnavox Company, published for the employees of the Magnavox Government and Industrial Electronics Company in the 1980s. As a footnote, longtime AWA member and historian Bart Lee went to Napa, California in 2015 to see the memorial sculpture commissioned for the 100th anniversary of the moving coil loudspeaker. He also learned that the farmhouse and shop building leased in 1911 by their founding company was still standing in 2015.